All right, so you have an answer key to this. This is for our limits test, our review. I wanted to go over a couple of them just to give you a little sampling, hear my thinking, even if you have the answers, kind of know what's going on. So let's look at this one. If you say what is the limit as x approaches -2 of f of x? So imagine I was jumping on this roller coaster. I want to check what y value does my graph squeeze into from the left and the right. So I'm squeezing in on that. And I don't care that the point isn't there. Even though the point's way down here, it's what y value am I squeezing in on from both sides. If it's the same answer, the y value is your answer. So that's why this one is 3. Let's see. Similarly, you could check, let me do one from one side. Let's say this one. What is the limit as x approaches 3 with a little plus sign in the exponent? That means from the right, because it means a number slightly bigger than 3. That's why it's a plus sign. So even though this limit would be does not exist, if I ask about it just from the right, I can answer that question. Because I'm going, okay, from the right, the y value it approaches and gets closer and closer to is a 4. Doesn't have to get there. Now, if you ask me this question, see how there's no plus sign? It implies I need you to check both sides. So if this one approaches 4 and this one approaches 1, they're not the same number. And if they're not the same number, you say does not exist. So yeah, good times. And then these are just like, if you see what is f of -2, it means what's the y value of the actual dot. So when x is -2, the y value of the dot is 1. Okay. All right. Now to the next section. I forgot to tell you can skip number 4 because we're not messing with trig yet in here. So, some of these are easy, like number 2 and number 7 both work with direct substitution. Don't forget that. Wait. Yeah. I do want to do 7. Let's do 7 because you should always try direct substitution first. First thing I should try in any of these problems is try plugging that number in. So if we try plugging that number in, I think my answer key might be wrong on this one. You will get -4 over, because I put a 0 in for x. Oh yeah, -4. The answer key is wrong. You put a 0, or no, it's not. Gosh darn it. Okay, you put a 4 in and you square it, and 4 squared is 16 minus 4. In the bottom, you put a 4 in, and you get 4 minus 4 is 0. Now, the answer key is wrong because it said the answer is 0, but if the 0 is in the bottom, you have yourself an infinity. Okay, it does not exist. More specifically, it's infinity. I should check if it's positive or negative infinity. I guess it goes from both sides. So yeah, the 0 on the bottom is undefined. It's the 0. If it was a 0 on top, you would have had the answer 0. So my answer key is wrong here. It does not exist. Okay. So yeah, let me do a different one now. All right, so let's try to mess with one of the radical ones. So, pick the top one. First thing you should try is plugging in a 1. This would be 1 minus 1 over 0. So 0 over 0 means I'm not done with the problem. So in these problems, you need to make sure that there's not a lot of room for this, but multiply by a very special number called the conjugate. And the conjugate looks exactly like this ugly thing, except it's going to be the opposite symbol in between. So instead of x minus radical x, you're going to say x plus radical x. And you do it to the top and the bottom. Okay, the purpose of that is when you FOIL the tops, it's going to get pretty every time. If you pick a conjugate, it will get pretty on top. Well, in this case, that thing will get pretty. Whatever you do to the top, you have to do the bottom. So let's look at how pretty the top gets. First times first is x squared. Last times last is negative radical x times positive radical x. When you multiply a radical by itself, it's like squaring a square root, and you're just left with what was inside. The only thing you got to be careful of is make sure you don't lose that negative sign, because it's a negative times a positive. The bottom's going to be ugly for a second. No big deal. Leave it ugly, because my goal is to try to get the something on top to cancel with something on bottom. Right now you might not see it, but try factoring the top. Just take out the GCF of x, because they both have an x in them. If I took an x out of there, I get x. If I take an x out of here, I get minus 1. And now you should see that these guys cancel. And as soon as they cancel, it's okay to plug that 1 in. I can try plugging the 1 in. If I plug in the 1 up top, you get a 1. If I plug a 1 in the bottom, you get 1 plus square root of 1, which is 2. And your answer is 1/2. So that's very similar to how you would do this one. And then you got a factoring problem. You got that one you just, what's number 5? Number 5 is just going to be a substitution, and it's very similar to the answer number 7. This one, just FOIL that out. It's going to be irritating, but if you're having trouble with this one, probably you'd like it better if it had numbers. But you're going to have to FOIL this out or know the pattern for it. It's a whole lot of keeping track of your stuff, but eventually stuff cancels out. All right, now to the piecewise function. How do I find limits? It's kind of like a choose your own adventure. You have to pay special attention to these constraints. So if you ask me a question of like this one, the limit as x approaches 2, well, there's only one of these 3 equations I'm going to look at when the limit as x approaches 2, because 2 falls in between here. So I'm going to treat it like this function as long as my answer, my x value, is between -1 and 3, which it is. So all I have to do is use this equation and plug a 2 in for x. So my answer is 4. Similarly, on this one, if you get 5, you think, okay, which one of these 3 situations do I land in? 5 lands you right here. So you have to treat it like this. You're going to be like, okay, that's 5 squared plus 2 times 5 minus 7. And you can, do the math on there. Easy peasy, right? The difficulty comes when you pick a number that is where these 2 things split. Because when I look at as x approaches -1, I see a -1 here and I see a -1 here. And that's because your graph could be a situation like this where you're approaching 2 different numbers. Now they might meet up, but they might approach 2 different numbers. So you got to be careful when you get one of these, I call them border numbers, because a -1 is part of this guy and a -1 is part of this guy. So you need to approach it from the left. That would be the top guy. And you'll check what happens when I put a -1 squared minus 3 into that equation. That's 1 minus 3, -2. And what happens when I put a -1 in here? I get the same number. If you get the same number, then your answer really is -2. If we do this other one and you plug in a 3, remember, see how 3 is part of both of these guys? So I'm going to have to test it in equation 2 and equation 3. If I plug a 3 in here, I get a 6 for the top. If I plug a 3 in here, you're going to have 3 squared plus 2 times 3, 7. If it comes out as 6, I'm fine. My answer is going to be okay. It's going to be 6. If it doesn't, then I have a problem. So let's see. 3 squared is 9 plus 6 minus 7. 9 plus 6 minus 7 leaves me with 8. If these 2 don't match, then your limit does not exist. It's a jump in your graph. These guys would meet up perfectly at that height. These guys would not, so you'd have a jump and your limit does not exist. 11 and 12 are a lot like our notes, except 12 is a little different because remember how we learned interval notation before? This is saying flip the paper over and tell me where that graph is nice. Where does it behave? So like I can draw this part without picking up my pencil. So from negative infinity to negative 4, not including 4, I could draw that chunk without picking up my pencil. And then I go to the next chunk you can draw. I can go from negative 4 to here, but then I have to pick up my pencil. So from negative 4 to negative 2, not including either of the endpoints, I can draw it without picking up my pencil and then keep going with that. All right, so here we come to this, and I'm supposed to find any points of discontinuity, say if they're removable or non-removable. We were just kind of doing that in class the other day. I want to factor because what I care about is discontinuities happen when the bottom of a fraction equals 0. Well, I can't tell when the bottom of this fraction equals 0 until I factor it. So what multiplies make negative 10 and adds to be 3? We got a 5 and a 2. Just got to make sure the plus goes with the 5 and the minus goes with the 2. So right now I'm concerned about when x equals negative 5, that's one of my bad places, and when x is 2. But I don't know right now if they're asymptotes or wholes. So how do I tell? Well, if it cancels off from bottom to top, it's a whole, and if it doesn't cancel off, it's a vertical asymptote. Those are two different kinds of bad places. So let's factor the top and see if any of these cancel. So two numbers that multiply to make 8 but add to be negative 6. That's minus 4 and minus 2. So that tells me, since it was removed from the equation, this is a whole and it's a removable discontinuity. Okay, this one didn't go away. Remember, I don't care about the top, I care about the bottom being 0. That's a bad one because it doesn't go away. So this is a vertical asymptote, which is a non-removable. Okay, it's a bad one. It's not continuous. Those are the only two places you have to worry about picking up your pencil, though. That's kind of cool. We kind of did this before. You want to make it so the two graphs come together and meet perfectly. So you're going to have to figure out what numbers to put here and here so your graph doesn't have jumps. And it's kind of like the other page, but you have to do a little work for it. You might have to move, figure out what number to shift it up. Don't worry about 16. We didn't do the intermediate value theorem yet, but we will later. Then we get to the last thing, which is limits at infinity. Okay, so let's do the bottom one first, and I'll jump back up here. Vertical asymptotes we just talked about is when the denominator equals 0. So here you can be like, the VAs are at x equals 2, right? The horizontal asymptotes, if they exist, are when we look, remember when you go way out to the right, positive infinity and negative infinity. So I just look at the biggest numbers and I simplify it. If it's equal weight, you get to just cancel and you get 3. So that means my graph approaches 3 out to the right and left. Remember, if it's top heavy, it goes to infinity or negative infinity. If it's bottom heavy, it goes to 0. And if it's equal weight, you can just cancel it. So now to this last one, probably the easiest way is to type this in your calculator. And I type that equation in my calculator, see y equals. And when I look at the graph, if you want me to say what does the y do as x gets closer to negative 2 from the left, I find x negative 2 from the left and I trace it, it goes down forever. That's negative infinity. Or if I went to 2 from the right, this is negative 2 from the right, it would go down forever. That's negative infinity. Or you could just type in a number like negative 1.999, or a number slightly smaller is negative 2.01. So there's a recap. You also have an answer key. Hope that helped out. Talk to you later, folks.